The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone. I would like to welcome back to another KevCAM night class tonight. Tonight, have Tim Micah helping out with any questions or concerns that come along the way for you guys. Tim, are you with us?
I am. Good evening, everybody.
And then as well as Greg Payton helping out with anything that I miss or overlook for you guys. So, all right.
Good evening.
Yeah. So I do see a couple new names in here. So just to let some housekeeping stuff here is we use GoToWebinar and everybody is in mute just to eliminate any background noise. There is a questions panel for you guys. If you guys have a questions, definitely feel free to ask them and just type those into the questions and Tim will read those off for me and we will answer your questions right away. These night classes are dedicated just for you guys, so feel free to ask as many questions as you want. Very laid back. And every night class is being recorded, so if you guys ever want to come back to it, you guys can go to the SolidCAM University channel and see every single night class in here, as well as live cuts, as well as quick tips and tricks. And Mark also does a fantastic job of doing short little how-to videos as well. Something new that just added this week in there is the playlist. And what I did is I went through and categorize all these for you guys. So if you guys are just looking for something with HSS or maybe HSR or just turning or night class with turning, it's all categorized for you guys right here now. So, all right, with that being said, we will get the ball rolling. Now, tonight is going to be a very short night class, but while I'm on this subject, let me drag this over for you guys. Tonight we're covering Cartesian versus polar for the motion control for more or less the mill turn side of things. I had a couple of you guys ask for this night class, so they submitted their idea and they got a free hat and t-shirt. So if you guys do have ideas on something that you guys would like to see in here, shoot those over to me via email. And I just put my email address in the chat for you guys. And anything that you guys have, shoot that over to me in email and we will add it into the night class lineup for you guys. Okay, so tonight's class, like I said, is Cartesian versus polar versus not having anything at all. And this is more geared towards the mill turn side of things. And for a reason why we would use Cartesian versus polar is maybe we don't have enough travel in our Y and we need to use the C-axis and some of our X-axes. So what we did here is set up a couple different cuts for you guys. Now, these are all going to simulate and look identical. So for this one right here, we're not doing any fourth axis stuff at all. But if we go ahead and simulate this, and I'll just single step it through, we're just machining off the front face to do that square with the Z pointed in the, or the tool pointed in the Z positive or in the Z negative direction. You'll see that it does that square. So we have nothing selected right here, but what happens is there is not enough Y or X travel for the mill turn machines. So if I hop over to our Cartesian cut right here, you'll see that we are doing a Cartesian cut using the X and C plane and using the face. So if I simulate this right here, it's going to simulate the identical to what was done before. As well as if I simulate the polar, it's going to look identical to that as well. So what's actually happening is it's all based off of the post processor and the G-code. So what I'm going to do here is if we do an XY cut, I'll open this back up here and we'll do a quick G-code. 1 second here, I gotta open up my settings, G-code, there we go. Okay, so here is our G code for our just X and Y cut right here. So you'll see that we have a lot of arc moves in there. We have our XY cuts, but there is no rotations in there at all. So it's just basically going around the perimeter. And like I said, it's all machine dependent, but a lot of times we can't make this cut just because there's not enough travel in the X or Y axes on the mill turn. So what I'll do is I'll just minimize this for a second, and we will go ahead and open up our Cartesian cut. Now with the Cartesian, what it will do is it will use the X, Y, and Z, and it will automatically convert over to a G12 or a G12.1 to do the XC moves. Now this is all converted over in the post processor, but one thing, I mean, we can choose our XC, but now if we go ahead and G-code this out, what we'll see here is just got to find it real quick here. Looking for a G17 XC.
G17's up.
Oh, right here. So, thanks, Tim. So right here is our conversion code to automatically convert this over. And what it will do is we can see that we're rotating our C-axis, but we're also doing arc movements as well. So what it will do is it will kind of contain it into a smaller bounding area, but still able to make the cut. So we're rotating our C-axis along with doing XY cuts right here. Now with Cartesian, it will do arcs. With Polar, it will not do any arcs at all, and it will do small little rotary moves with line segments. So let's just go ahead, and we got this one named as Cartesian. So we'll just go ahead and minimize that for a second. And between Polar and Cartesian, we can tell it to switch it over to XC, YC, or ZC on which axis has the most amount of travel there. So now we'll go ahead and hop over to Polar right here. And we're going to do the exact same thing, Polar with XC now. And now, like I said, what we'll see is a bunch of small little line segments along with a bunch of C moves in here. So you can see right here is we have a whole lot of X moves and small little moves going along with the C axis as well. Now to do Polar, what you always need to do is turn on the approximate arcs by lines with tolerance, so it takes out all the arc movements. Oops.
And in addition to that, Kevin, you need to check the interpolation by tolerance as well.
Sorry.
For the point interpolation.
Yep, great call. So these two need to be checked for the Polar to take effect. Sorry.
As a matter of fact, why don't you bring up that last G-code that you did?
For Cartesian?
No, for the Polar, because that'll illustrate why the interpolation by tolerance needs to be checked. So anytime you're doing this kind of Polar cutting, or any kind of cutting for that matter, it is point to point in the G-code. What are you doing?
I just regenerated.
We needed the old one.
Oh, you need the old one?
Yeah.
Okay, so let's calculate.
Okay, go ahead and scroll down a little bit. So right there at that first singular C move, we see the move right above it is at X901, which is going to be the diameter of the part, and we're at C33.708. And its next move is going to be the C negative 33.708. So all that is a rotation move, which means that tool is only going to be moving in a arc fashion to match that rotation. Now, by doing the interpolation by points, what you're doing is you're breaking up that line segment into a bunch of little points. That way you can change that radius value and kind of fake that straight line as it's going. So instead of going from one corner to the next as a point to point, like we normally would if there was a straight line in between it. Go back and show your geometry, Kevin. So essentially what you're seeing with that toolpath is one line of G-code is approximating that line. And the way that we're doing it with that rotation is it's trying to force the tool to go between that rotation, between those 2 points. So what we try to do is by checking on the interpolation check mark is to break up that line segment into a whole bunch of tiny line segments. That way you get a change in radius the entire time moving there. I wonder if it'd be better to illustrate. Can you open up a new sketch in SolidWorks, Kevin?
Bet.
And maybe a new part file. That way we have something blank, or maybe we could see it on that file. And then just convert the entities on that face. Is it not going to let you because you're in assembly mode? We may have to get into the part itself. But essentially what we want to do to demonstrate it is we're going to need a point in the center of rotation. And what we're going to do is a 3-point arc that goes from that center point and then just touches the vertices of that square, or we can do
so you want a line from right here to the center to the point?
Actually, it's going to be a 3-point arc that's going to be from the center and then touch 2 of those vertices. Because what that's going to do is it's going to draw that arc that's going to approximate that movement.
For some reason, my toolbar got all messed up here.
I'll tell you what, why don't you go ahead and make me a presenter, and that way I could just do a simple sketch here for that won't interfere with your file. All right, what screen can you see?
We can see the email screen.
Okay, so let's go screen 1.
Here you go.
All right, and what I'll do is I'll go a square to keep it the same. And we'll make that a true square. So what we're doing with that toolpath, and we'll do this as a center point arc. Okay. So this arc here is approximating what that toolpath is going to be, because as we all know, G-code is point to point. We're going from one location to the next. So in polar interpolation, we're going from this point to this point here, and the only thing we're moving is that C-axis. So by doing that rotation, we get a swing like this, which isn't the straight line that we're looking to cut. So what we try to do by breaking it up with that interpolation check box is we're going to come in and we're going to put in a ton of points along this line. And the distance between those points is going to be that tolerance value that you see in that checkbox. And so what that does is it allows our X to be the function of this radius here, and it's going to be output at all these locations. That means that we get the tool to update at every single node point, which means that we can approximate this straight line as the tool is going around much better than if it isn't unchecked. So anytime you're doing anything that is polar, you're going to want to make sure you have as much point data as possible. Now, I think where Kevin was going with that is because you're putting in tons and tons of point data, you're going to have a huge file. So let's go back to your screen, Kevin.
Yep. So one second here.
That way we can compare that to Gcode output again.
Yeah, and what Greg was saying with those points is, by this turned on, those points are created every basically 4/10.
Now, depending on the resolution that you want, you can change those values. Just know that the smaller the number, the closer you're going to get to a true line, but the more code you're going to have as a result. So yeah, let's go ahead and take the one on the left, because that's the one that does have the interpolation turned on both checkboxes, and kind of scroll through that thing. That way people could get a feel for just how much code there is there, just to cut that one little square. Quite a bit.
Yep. Versus over here, it's a lot much smaller.
And especially if you compare it, do we still have the Cartesian output?
Yep. So here's the Cartesian right here, and that's it right there.
Which you can tell it almost fits on one page. So not all machines are going to be capable of doing the G12.1 or G112 or G12 polar interpolation conversion. So essentially what you're getting with the G12.1 is everything that you see on the left-hand side of the screen, we feed in values with that G12.1, and the machine's controller converts it over to what you see on the left, although we can feed it Cartesian coordinates. Let's go ahead and bring up, leave the Cartesian up there, and bring up a Gcode of the XY. All right, now what you're going to see with the XY is, take a look at the same values for that first G3 move. Actually, let's look at them side by side. Oops, sorry. Okay, so the XY cut is a planar Cartesian cut. Yeah, it's actually going to be similar to the one right below it. But you look at it, you have X 0.7495, Y 0.5, R 0.2994. Now take a look at the line directly underneath the highlighted line for the Cartesian interpolation, and you have very similar values, except we're just trading out the Y value for a C value. And that's why this is called Cartesian, because it's mimicking that of a Cartesian planar output, except we're just trading out the Y-axis for the C-axis and letting the machine's control handle the conversion to all the different points that it needs to approximate that shape.
Very well put. Better than I could put it.
So yeah, if you don't have the Y or the X-axis travel, and a lot of mill turns don't, I think a vast majority of them, you might get a ½ inch in negative X, which by the time you factor in the radius of your end mill, you start running out of travel real quick. Then you really need to start looking into using that C-axis rotation if you have it. And if you've got this G12.1, I believe most manuals call it polar interpolation, then yeah, definitely use that, because it's going to keep your code nice and short. You should be able to look at this code, and it's going to look very similar to what you're used to in XY programming, and much easier. But some machines, especially older machines, don't have access to the G12.1, and that's when you're going to want to use those polar cuts.
Yep, over here. And once you guys have this set up for your machine, because you guys are going to know if your machine supports it or not, even running a sample part, just like what we have drawn up right here. Make sure you guys save that out as a template, so that way, you know, if you're not using this on a day-to-day basis, you can at least have it saved out for doing, you know, for your mill turn, for face moves, and it'll already be set up for you guys for Cartesian or polar, whatever your machine can support, or just doing the regular XY cut there. It's, like I said, or Greg was saying, is it's very machine dependent on what your guys' machine can support. So this one is on a Mazak, so we can support all the different ones, but it's per machine basis. So any of those come up, or, you know, if you guys want to run that code and you guys getting an alarm out, definitely feel free to give us a call, but it's more than likely it's going to either have to be switched over from Cartesian to polar to XY, which is just no fourth axis move at all for the motion control turned on for you guys.
Hey, Kevin, I think you said that this topic was requested by some of the guys that are coming to the class here. I guess guys in there looking at the questions, is there any anything there that you guys have further questions about with this, and or is this kind of covering you know, what you were looking for to do in this class? So just feel free to put some question or comments there in the questions panel. Thank you, Ronnie.
Yeah.
Now, let's do note that, go back into the operation, Kevin.
Yeah.
Because you do have quite the international following as well. The way that the code is coming out here is indicative of how things are posted here in the United States. So the way that we're treating it here is the Gcode output. So if you have the coordinate type selected as polar, the Gcode output is going to be polar-based values. If you set it to Cartesian, you're going to have the Cartesian conversion-based values. I know some of the other post writers internationally do it kind of based off of how it's listed in the manuals, and it can be listed a couple different ways. But if it's polar interpolation is what some of the manuals refer to the G12.1, it is possible that the coordinate type would be polar to get that G12.1 output. But here in the United States, you're going to find that the coordinate type refers to the Gcode output that you're looking to generate.
Yeah, that's right. I forgot about that. So I guess in a short sense of things, polar is going to have your short rotary moves that has a bunch of line segments. Cartesian is going to do the conversion for you using the G12 or G12.1, or we go to the XY, and we'll say yes, or we can, if you guys have the ability to the travel, you guys don't need to even use the fourth axis at all. So hopefully that kind of makes sense for everyone. I know it's kind of a lot to take in, and we have 3 different tool paths right here doing all the exact same thing, but like Greg was saying, it's all dependent on the machine. So we can have 3 different styles of code for doing the exact same cut. So it's whatever you guys are looking for your machine to be able to do. So hopefully that really makes a lot of sense for you guys.
Yeah, we're even finding that the guys that have the ability to do the XY planar cuts are actually able to make those cuts much faster because the XY axes are faster than the C-axis rotation of the spindle. So if you have the ability to do the XY planar cut, you're going to have a much shorter cycle time just due to the machine being able to move faster. But that's not always the case. And so hopefully if you guys do have to choose a way of using the C-axis, this helps make more sense out of what your options are.
Yep. And I don't see any questions, so hopefully we didn't fog over you guys' eyes too much there, but if you guys do have questions going forward, again, getting pretty much everything that we can cover on the polar versus Cartesian versus not having anything at all. I did see, Scott, I see that you raised your hand. Do you have a question? I don't see anything there, but I guess what I was getting at is if you guys do have questions, for those of you guys that are watching on YouTube, feel free to email me, and we can definitely go more in depth on your post and your particular machine. Like I said, we kind of left this as very wide open on a machine that is able to support all three types here. But if you guys do have questions going forward, let us know how we can help you guys out in any way possible. So, am I missing anything, Tim?
We do have a question there. If you have machine sim, will it show the different cut types? Scott, that's what Scott was asking.
Yes. So when they build your machine sim, it is all based off of your post processor. So it will show you. So when we play this through in Solid Verify right now, you guys will see that the tool is just going around. So it's not the actual spindle turning, or for our Cartesian versus polar, all that stuff. It's just the tool going around. Where in machine sim, it takes into factors of the different codes that are in there, and that's why when you guys purchase a machine sim, it is 100% tied to your post processor. So it will show those moves for you.
That's a good question. That's appreciate that, Scott. With machine sim, you'd see the fourth axis rotating versus just a plain XY. It'd be just moving across the top.
And I don't know if I have a machine sim. No.
In machine sim, the polar and the Cartesian are going to be simulating the same because they're approximating the same thing with just different code outputs, but the actual movement of the machine is going to be the same. The only one that you're going to see that's different would be the XY planar cut, which should have the C-axis locked, as opposed to the rotary movement, which will show the Y-axis essentially fixed and the X and C-axis moving in conjunction with each other.
Yep. Great question, Scott. Any other questions, guys? Ronnie, it's good to see you back in here. I missed picking on you 2 weeks ago, so it's good to have you back. But I don't see any other questions in here, guys. So if you guys feel like you don't want to ask a question in here, like I said, send those over to me via email, and we'll get that squared away for you. But with that being said, just want to thank everyone for joining the night class tonight. I know it was a little bit shorter than normal, but hopefully got a lot of the clear the air for you guys as well. So next week.
And Kevin, I just wanted to give you a big thank you for hosting these classes time and time again. Greg, appreciate your input here tonight. You did a good job with adding some additional explanation of those different values and what they do. So I'll let you get back to it there, Kevin, to wrap up.
Yeah, so next week, well, both Greg and I will be on site. Greg will be in Philadelphia. I'll be in Indianapolis. So next week we will not have a night class, but after that, we'll be going over some better toolpath options for you guys on just different parts, just random parts more than anything. And so, like I said, if you guys do have ideas, send those over via email, and we will add those in there. And anything you guys would like to see different, we can change that up for you guys as well. So, all right, with that being said, we'll end it off here, and just want to thank you guys again for joining the night class, and have a great rest of your week. All right, bye-bye, guys.
Bye, thanks.